Okay, question number 1 is to display the numbers from 1 to 50 on a screen. And so we're going to do that right now. I've started with a loop that counts from 1 to 10. Remember, this is our variable that's going to control how many times we go through the loop. 1 is our initialization for that variable, so count is going to start at 1. Here's our body, where we display count. And 10 is going to be the exit. So when count is 10, it's going to stop. So when we run it, we get it from 1 to 10. So if we want to go from 1 to 50, we just need to make the exit 50. And when we run it, there we go. Now we're going to scrolling all the way down. I believe the question wanted us to display to the side. So we're going to add in there. We're going to put a space between each one and then the dot dot so that it will stay on the same screen or same line. And there we go. We get it all displayed out. Question number 2 was to display the numbers from 30 to 70 on the screen. So if we're going to exit at 70, we're going to change our exit. And if we're starting at 30, we're going to change our initialization so that we should get the numbers from 30 to 70 coming out on the screen. Our third question is now going from 25 down to negative 25. And it wants us to decrease by 1. So now we're counting down, so after the 4 we now have to put decreasing count. We're going to start at 25, so that's our initialization, and we're going to end at negative 25. So we put in negative 25 and let's run it, and there we go, from 25 to negative 25. Question number 4 is dealing with displaying the numbers from 14 to 30, but we're only going with even numbers, so we're expecting to see 14, 16, 18, and so on. So to modify that, first of all, let's get the initialization, 14. We're going up to 30, and because they're going to go every other number, we want to add by 2, so we put the by 2 on the end there. This will go up by 2. If we wanted to do odd numbers, we would start with an odd number here. Let's run it. We should see 14, 16, 18, all the way up to 30. Five is all the numbers from 1 to 51, so this one's odd. So we're already going up by 2 from my previous question, so we're just going to go make that 14 a 1 to initialize and 51 to stop. And when we run it, there we go. So see, it makes no difference whether you're going up by odds or evens, it's always by 2. What makes the difference is where you initialize. The 6th question was to display all the letters from A to Z. So this is letters now, so characters. So the difference is we're going to put characters in here. Now remember, characters are recognized by single quotes. Okay, double quotes are strings. But if I want to start at capital A, I'm going to put a capital A. And I can go to capital Z. And I better get rid of this by 2 from the previous question. And so this should count from A to Z. There it is. Question number 7 is now working backwards with the lowercase, so it's Z to A. So all I have to do is put it to start at Z and put this at A, but now we're actually counting, we can think of it as counting down because we're going backwards on the alphabet, so we have to put decreasing. So we're decreasing from Z to A. If we run it, there we go, Z to A. So our next question is dealing with moving a circle across the screen. So it's a little bit more fun to look at. So if we're going to draw a circle, what we would do is we would use a draw dot fill oval, or even a draw dot oval. Fill will of course color it in. And what we would do, maybe if I'm trying to draw one of them, I would start it at 0 because I want it on the left hand side. Remember, I'm doing the center of this circle. And maybe halfway up the screen. So max y div 2 And then I need a radius, so I don't know what's a good radius. Let's go 50-50 just for now, and a color. I'm light green. So now if I run this program, it's not very exciting. I've got my half circle right there. Now, what do I want to actually happen? I want that fill oval to move across. So if I'm moving from left to right, what actual value is going to move? Well, it's going to be this 0. So this 0 actually represents what my counter variable is going to be. So I can do a 4, and then I can start it with a value. How about circle x, circle x. Let's go with circle x. Circle x. And we're going to start it at 1, and we're going to go all the way up to max x, just to get it to go across the whole screen. I now need an N4, and I'm going to press my indent button, make it look all nice. And instead of this 0, I want that circle x. So let's run it, see what happens. Whoa, it went across the screen real fast, and you notice it's also filled it all in. So what we need is a couple of things. Let's maybe put a delay, and we'll put a little tiny delay on it. Now if I run that, I can see it's growing. But what's happening is I'm not seeing circle, I'm seeing this shape that's elongating. And so what I probably want to do here is I want to clear the screen. So if I clear the screen every time, now when I run it, and now I see my circle. Now you see there's bits of glitches, and we've talked about this before. When I see those glitches, that means I want to use that off-screen only. So I go up to the top here, and I put in off-screen only. And every time I want to display something on the screen, I need to do a view.update. So it's usually at the bottom. Actually, I should have that probably in front of the delay. Put it in front of the delay, so that way the view.update is instant, delays 10 seconds, clears the screen, and so on. Okay, and let's see what happens. And you can see it's much smoother now. Okay, we'll stop it there. Question 9 is a little bit different. So we want to start with a circle in the center of the screen, and then what we're going to do, we're not going to fill it in, we're going to just draw it a circle itself, and we're going to build it up so that it the radius is going to grow. So just if I start with something new here, let's start with a draw dot fill and not oval. We're going to start in the center of the screen, which is max x div 2, max y div 2. Let's go with 50. Oh, to start, we'll start with, well, 1 in each direction, x and y, and then we need a color. So let's do this in red. Now if I run this, I've gotten an error. 1, 2, 3, 3, 4. Oh, draw dot fill. What's draw dot fill? Draw oval. So now if I run this, there it is. I got a little wee open circle there. Now what I want is that radius to grow. So the radius is both of these. So let's pick a value. Let's call it circle radius. And I'll copy it and I'll just put it into here. And now we need a loop around it. So we're going to have a 4. We're going to have circle radius. And we're going to count it from 1 all the way up to, well, let's go max. Oh no, I think it says 256. And then let's end the for loop. And we'll indent, of course. And so this should start at 1, then go to 2, then 3, then 4. And let's run it. Oh, error. I got an extra dot there. And then now let's try. Oh, got there really quick. So let's put in a little view.update so we can see it grow. And a little delay. And let's run it. There it goes. Really nice effect there. And if we wanted to, we could clear the screen and get individual circles up, but I kind of like that better. The only difference between question number 9 and question number 10 is we want each circle to be of different colors. So before it was red, so I need this red to change from values of 1 up to 256. Well, notice circle radius is already going from 1 to 256. So all I need to do is put in circle radius into that position. So yeah, I've got 3 spots, all with that circle radius variable, but it's counting from 1 to 256, so my radius are both changing in both directions, and the color of my circle is changing. So let's see this effect. You can see it nicely grow out with all those 256. Oh, max color went out of bounds, so it's actually from 0 to 255. I probably have to do it. So let's just change those values to 0 to 255. Now it shouldn't crash on me right at the very end. No, we actually got it finished. For this next question, we want to build up squares. So it's going to start with a very small size, and it's going to grow up, and everything's one color only. So best way to do that is probably an easiest way is to start it over in the 0, 0 position. So let's just draw a box, view.box. And we're going to start it at 0, 0. And for instance, this value could be 1, 1, 2, 2, 100, 100, and so on and so on. So it really becomes the length of the box. So let's go call it box length. And that would be the x coordinate. It would also be the y coordinate because we want this to be a square. And then comes the color. And let's put it at red to start. So you can see we want box length to be the loop. So for box length is 1 up to, let's go max y. I think that's what the question says. Oh, only 2 dots. And let's do an in loop. Now we'll probably have to, delay it so it doesn't build up so quick. And let's try it. Oh, 2 errors. View.box. Why do I have view? Let's go with draw.box. And now let's try it. There was one, I got an end loop. I'm not thinking very well here. N4. And now let's run it. And it doesn't seem to be growing. What did I do wrong? Oh, look at that. That tells you. That came up. That means I didn't do a view.update. So let me put on a view.update. I gotta remember I'm keeping the off-screen only working here. So when I run it now, there it's building up. Very nice. Good. Done. Now for number 12, it's the same thing. We just have to get it to work with all kinds of different colors. And we have an option of either using random colors or to use mod and get it to repeat the colors over and over again. Let's try mod first. If you haven't looked at mod, what mod is, and we'll look it up in the help here. It's an operator. It's like addition, subtraction, multiplication, and division. It's a 5th operator. It's called modulus. And the modulus operator produces the modulo of one number with another words. With another. In other words, the result is always a number between 0 and the second operand. So they give an example here. 7 mod 2 produces 1. 12 mod 5 produces 3. It's when you do division, when you go 7 divided by 2, it's looking for the answer of the remainder. So the remainder is 1. There's 1 left over. 12 divided by 5. 5 goes into 12 twice. There's 2 remainder. That's a mistake there. It says produces 3. But the key thing here is it does a remainder. And in this example here, what we want to do is we're going to count up to max y, right? But we can only have numbers up to 255, really, 0 to 255. If it gets to 256, it crashes. And I'll just show you, it'll crash. If I go in here and I put in box length, so it's going to count up from 1 to max y. It's eventually, oh nice, eh? Look at that, but it crashed. And if you look down at the bottom here, it says, oops, color value of 256 is out of bounds. Max color number is equal to 256. So it can't go over 256. So to get that, to prevent that from happening, what we do is we try to get it so that when it gets to 255, instead of going to 256, it goes back to 0 and it starts again. So it goes 0, 256, and then back to 0, back to 256, and back to 0. So how I can do that is I do box length mod 256. If I mod something by 3, that means I look at all the divisors by 3. So for instance, 7 mod 3, remainder of 1. 8 mod 3, remainder of 2. 9 mod 3, remainder of 0, goes back. 10 mod 3, remainder of 1. 11 mod 3, remainder of 2. And so on. 12 mod 3, remainder of 0. It goes back and forth over and over again. So if I mod by 3, I get possible remainders of 0, 1, or 2. If I mod by 256, I get remainders possible of 0 up to 255. It's always one less. That's exactly what I want. Now when I run it, it won't get above 256. It'll just go back down. Not box length, it goes on, but this calculation, box length mod 256. So when I run it, I get all my colors and I get them in a row because it's counting all the way up. Look, it didn't crash. It's gone all the way up, and there we go. Okay, so that's one thing to do. We can do it that way, and that just scrolls through basically all the colors over and over again until we get to max Y. Now the other option was doing a random number, and the other thing we could look up was ran.int. That's what I put down. So if I look up ran.int, it has two integers, low and high, and it returns an integer value. So that means I could use this to take the place of a color. So the low value is the lowest possible integer value I want. The high is the highest possible integer I want. You can see in this example right here, it says rand.int 1 to 6. That means it's like a dice roll, 6-sided die. So it's going to roll from a 1 to a 6, and it displays that number as an integer. So that when I run this little code, it would display a random integer every time from 1 to 6. So I can use that here instead. So I could go rand.int, and then my lowest would be 0, my highest would be 255 for all the different colors. So this is taking the place of my colors. Let me just make sure I type that in right. Yep. Okay, and so when I run it, now it's just a random color. It's not the same as what we had before, but it's a random color every time. And we're done. So if I were to run this again, it may not look a whole different, but I will have different colors in each position than what I had before. Okay, done. Well, we're up to the 13th one, and then the 13th one we're kind of moving away from graphics for a bit, and we're looking at trying to come up with a t-chart or a table of values like we do in math for the equation of a line y equals 3x plus 2, and we're going to do it from -5 up to 5. So the first thing I kind of need to show is, well, probably let's introduce the variable y. Alright, so y is going to be an integer value, and we're not going to assign it any values yet, but it's going to be used based off whatever x is. We can put in headings, so let's put in the x value, and we're going to tab over a bit, and we'll put in the y value, so that when I run this program, there. Now, maybe there's a way I can put in a bit of a slash in the middle. How about that thing? I wonder how that would work. Maybe move it over a bit more, or is that okay? We'll see. We'll see. If I want to get really fancy, it's not really fancy because it's not graphics mode, but I could go like that. But I kind of need some backslash t's in there too. And I kind of gotta line these up a bit. There, how's that? Well, that actually came out all right. And I kind of need another line here to continue on that line. Run that. Ooh, Getting a nice little one. Anyways, let's get into our loop. So every time through the loop we want x to be -5. Plug it into the y and output the x and the y value. Increase x by 1, goes to -4, and repeat all the way up until we get to 5. So for loop, we're going to use x colon -5 dot dot 5, so it goes up. And I need my n4. Just indent so it looks a little better. So the very first thing we can do is figure out the y. Y colon equals 3 times my x plus the 2. There. And we can put out those values. So let's put out x. And let's try some format modifiers here. Colon 5, colon 6. 1, 2, 3, 4, 5, 6, 7. Colon 7. And then we hit a \t. We do our line. We do our \t. And 1, 2, 3, 4, 5, 6, 7, 8. Let's put out the y. Colon 8. I don't know. Let's run it. Oh, didn't like it. Oh, I forgot quotes. So comma, quote, quote, comma. Let's run that. Oh, not so bad. You know, it's nice and lined up. I'm noticing my y value is over too far. I'm going to get rid of one of these dashes. And let's not do colon 7. Let's go colon maybe 3. So it kind of puts it more in the middle. And this one a 3 too. Let's just try that. How's that? That looks good enough. We get in a kind of a t-chart. \t's I could take away maybe, but it's kind of nice to get it nice and lined up. But it goes from -5 to 5, and I get all the y values. So our next question is trying to show in graphics the actual line y equals 3x plus 2. So remember, our pixels start at 0, 0 in the bottom left and go up to max x, max y up in the top corner. So what we want to do is think of this as if it was in the xy plane, the first area, your positive x and positive y. And that's what we're going to try to graph. Now we're going into graphics mode, so I already got that. And we're going to introduce a 4, and we're going to do the x. Maybe we should go up for a second and introduce y again like we had last time. So var y is an integer, and we're going to do for x colon 1 dot dot max x, do our n4, and we got to calculate our y. So this is just like last time with the table of values, except we're actually going to graph and plot these points. Y colon equals, what do we want? 3 times x plus 2. We'll just indent, make it look a little nicer. Now, some of you have tried draw a line. I know I'm going to use draw dot dot. And draw dot dot requires just an x and a y and a color. So I seem to be going with red in this video. So let's go with red as our key value. So now let's try to graph it and see what it looks like. Oh, it came up pretty quick. It's a little faint, but there it is. Let's put a little delay so we can see it graph. And I wonder if I can get a, let's just leave it at red. There it is. It's growing up very quickly. Draw dot dot is little pixels, so I'm drawing 1 pixel at a time. So it's not very dark for that reason. So they're all integer values, so they kind of miss all the what we call rational numbers, all the decimal places in between. So it's not drawing a complete line, but it's still what we want. For this next question, we're back out of graphics again, and we're into a question that is almost the same, if not the same, of one we did with the loop question, where we're going to get a number from a keyboard, and then we're going to display from 1 up to that number. So let's get a variable first. Var, we'll call it input, and we'll call it an integer. Very nice, polite prompt. Please enter a number, and we will get that number. And then we need to count, so we need our count, and it's going to go from 1 up to, and our exit will be that input number. And 4, and we can just do a put count. Let's run it. Please enter a number. How about 10? 1 to 10. Let's run it again. How about 100? Oh, I know what I was supposed to do. I was not supposed to print it out sideways. Or scroll it. We need it to go across. So we'll do it like that. Now let's put 100. And there we are. Good. For question number 16, it's almost the exact same, except for now we're going to put a starting number and we're going to put an ending number. So again, we did this with loops. Please enter, I'm going to change this to be a starting number, and maybe we'll get more meaningful variables. So how about start and end? Oh, end's no good, it blackened. So it's already a keyword. So ending, how's that? And just for fun, we'll put starting. Get starting, and then we'll put please enter an ending number, and we're going to get ending. So count's going to be, our initialization is starting, and our exit is ending. So when we run it, please enter a starting number 1, ending number 10. There we go. Run again. Starting number 100, well, or 10, ending number 76. Okay, second last question. We're going to write a program that asks the user to input how many perfect squares they want to see, and we're going to display that many perfect squares. So let's start out with a variable. Let's call it number. For number of perfect squares, we'll make it an integer. So let's start with the good prompt. Put, please enter how many perfect squares, starting from 1, you wish to see. Get number, and we'll do a for loop for count, colon, 1 dot dot number, do an end for, and we're going to display, remember how to do it, count times count. That should be 1, then count is 2, that should be 2 times 2 is 4. And then we'll make sure it comes out on the side. Let's scroll. And let's run it. So let's say 10. There's the first 10. Let's say 25. Goes up 625. Good. Let's say 112. Ooh, up to 12,544. We're good. All right, last question. This one is tougher because we haven't done sums yet, but we will. And we're looking at a factorial. Now, if you haven't seen a factorial before, it says, the example says 5 factorial can be calculated by going 5 times 4 times 3 times 2 times 1. And that's what we're looking at. So that actually is equal to 120. And we should make sure it does work there. So the thing is, though, what I want to have happen is, first thing I want to do is get the 5 times the 4 to happen. And I want to remember that. So I'm going to kind of make a, let's do some commenting here. We're going to put a slash star star slash just so we can write out our thing. I'm going to have a sum, and I'm going to have a counter variable. Okay, not a sum, but a product, because we're multiplying. Now, when the count is 5, or even at the very start, what I want is I want the product to start at 1. Okay? That way when I multiply by anything, it'll be 1, or be that number. So at the very first time, I really want to take that 1, what it is now, and multiply it by 5. Actually, I'm going to go at a different way. Let's start the other way. Let's make count 1 and work that way. So, first time I'm going to take 1 and multiply it by 1 and make it 1. So I'm multiplying it by that 1. Then what I want to do is I want to increase my counter. So make it 2. Now, figure out my new product. I want to take that previous product, which is 1, and multiply it by 2. So it becomes 2. This then becomes 3. Well, what I want to do is I want to take the product that I'm remembering, the 2, and multiply it by that new 3. So that works out to be 6. And you see I'm working at it backwards. 1 times 2 right here. And then that times 3 will be this. My counter becomes 4. I'm going to take that previous product, which is 6, which I found from 1 times 2 times 3. 6 is going to be multiplied by 4. Gives me 24. And my count is now 5. I got to go that 24 times 5, and I'll get that 120. So counter becomes 6, or whatever. I should be done at that point. But the product, how did I do inside the loop? And the loop is happening here. You can see it's going 1, 2, 3, 4, 5, this number right here. So that's actually 1, 2, 3, 4, 5. That's actually that count. This value here, this 1, is actually that sum. The 2 is from that product, 6 is from that calculation. 24 is from that calculation. So the product is actually equal to itself, because that was what its previous value was. The 2 came from here. The 6 came from that total, times the current count. That's what we're going to do in our question. That's the key thing. So I'm going to introduce a variable called product, and I'm going to make it an integer, and I'm going to set it equal to 1 to start. See, if this is a 0, everything stays 0. If this is a 5, then I've got to multiply 5. 1 doesn't change anything when I multiply, so it's a good one to start with. I do a for loop, for count, colon, 1, dot, dot, 5. I'm going to assume it's 5 just to start, then we'll put in the prompt. We'll do an end for. Inside here, we're going to figure out the new product each time. So the product becomes itself, so what it was previously, 1, 2, 6, 24, whatever, and I'm going to multiply it by the count. And then I'm going to display it. No, I'm not going to display it until the very end. I'm going to let it work through there. I might display it just to show you how that product is changing. And then at the end I will say put, how about 5 factorial is, and I'll put out the product. Let's just run this. There you go. You see I'm putting out the product. It's that 1, the 2, the 6, the 24, 120. 5 factorial is 120. So it works. So what I have to do now is put in a little prompt. So I can do put, please enter the factorial. Get, I guess we need a variable called factorial. So let's go var factorial. We don't need to give it a value. Scrolling off here. There we go. So that's going to be our number that we're going to multiply up to. So that'll be a factorial there. And that'll probably be it. Oh, the other thing is that I'm not doing 5 factorial every time. I'm going to do factorial exclamation mark. So whatever that is will come out with an exclamation mark. So let's run it. 2. 2 is 2 times 1. So I should see 2 times 1. 2 factorial is 2, right? I can leave this put statement in here, or I can remove it. I'm just going to comment it out so it looks cleaner. So if I put in 2, I get 2 factorial is 2. If I run it again, let's go with 5. 5 factorial is 120. Go it again, we get 10. 10 factorial, which is 10 times 9 times 8 times 7 all the way down to 1, is 3,628,800. So a big number. And so on and so on. And so that's your first look at trying to have another variable involved in the loop and holding that spot. We will be doing sums, which is almost exactly the same. It's just sum is going to be starting a little differently because you don't want the sum to be 1, you want the sum to be 0, so there's nothing added in there. So we're looking at things like the sum of the sum of the numbers from 1 to 10.